All right, please, can you see the screen?
Yes. Yes, sir.
Okay. So now after finding the ranks, then you find what we call the difference between the ranks. Okay, so you just either subtract the rank of X from the rank of Y, or the rank of Y from the rank of X. Then you square them. Okay, so the D is rank of X minus rank of Y. Then you square it, so all squared. Then you find the summation. That's the sigma D squared. The sigma D squared. When you are done, then you use this formula. 1 minus 6 sigma. Please check this thing here. It's not supposed to be like this. It's not sigma D all squared. This is different from sigma D squared. Okay, so it's sigma D squared. So this bracket must go away. Over n times n squared minus 1. That will be the Spearman's correlation coefficient. The Spearman correlation coefficient. So let's use this. There's an example here, but let's use this one. Okay. The Spearman's correlation coefficient is also between. It's also from -1 and 1. Okay, just like the Pearson's, as I said earlier. The interpretation to it the same. It's just like that and the Pearson. So now, let's look at this question. This one, the ranks have already been given. You see, so we don't have the data. It's just the ranks that we have. So the first one is ranking econs and then ranking stars. So we already have the ranks. So all that we have to do is to find the difference. Okay, to find the difference. So what we do is that for the difference, subtract R2 from R1. So 1 minus 4, you put your answer here. 2 minus 8, you put your answer here. Then you square them, square all the observations and the D. When you square them, then you sum them up. So sigma D squared here is 132. So you just go to the formula. So 1 minus sigma D squared. The sigma D squared is 132. Don't square the 132 again. The 132 is the value of the sigma D squared. So 1 minus 6 times 132 divided by n is 10. You can count them. See, the highest rank is 10. So we have n to be 10. So 10 times 10 squared, which is 100 minus 1. That's what we have. So do this and we are getting 0.2. 0.2. So one, if you want to know the nature of this correlation or relationship, you use the sign. The sign here is positive, right? So there's a positive correlation between the economics and then stats. Okay. And then you talk about the degree. 0.2 is less than 0.5. So though it's positive, it's weak. So the result indicates that there is low or weak positive correlation. So this will be the interpretation. Okay. So this is the case where the ranks are given in the question. So if it happens like that, it's just straightforward. You just find your D, find your sigma D squared, and that'll be all. Okay. But let's look at the case where the ranks are not given. So we are given the quantitative values of X and Y. So we will have to rank them. Okay, we will have to rank them. This paper use the descending order. So if you are using descending order, then if you take X, 17 is the highest number for X. Okay, so 17 will be 1 for the rank. If you want the rank of 1, 17 is 1. The next highest number is 16. So 16 becomes the second rank. The next one is 15. It becomes the third rank. The next one is, I think, 14. 14 becomes the fourth rank. Then 13 becomes the fifth rank. So you do it for all the observations of X. Then you go to Y. If you go to Y, 46 is the highest number. So 46 becomes the first rank. 36 becomes the second rank. 35 becomes the third. So you have to rank all the Y observations as well. When you are done, we are just left with finding D. So R1 minus R2. 1 minus 2 is -1. 5 minus 1 is 4. So you do it for all the observations and square them. After squaring them, find the summation. So sum everything up and then you get 44. So come and put your 44 here. N is 10. So just go through the steps, and this is what you are getting. This one, there's a positive correlation, and 0.7 is greater than 0.5. So we say that there's a strong or high positive correlation between X and Y. Between X and Y. Please, is that okay?
Sir, please ask a question.
Okay.
So you see the arrangement. Can you do it like, let's say, from 17 to 15 to
No.
hey, from 17 to
No. If like you wanted to arrange the numbers in descending order.
yes.
No. If you do that, the thing will be wrong, because if you do that, then for Y2, 46 must come first, right? When you do that, the difference will always be 0, because if you are arranging the variables in descending order, then this here will be 17, here will be 46, here will be 16, here will be 36. Now, if you are ranking them, 17 will be 1, 46 will be 1, 1 minus 1 will be 0, 15 will be 1, 36 will be 1. So 1 minus 1 will also be 0. So just keep them like that. Don't change them. It's supposed to be like this. Okay.
Okay, thank you.
All right. Please, any other question? Any other question? Okay, let's continue. So this is an example that you can go over later. Now, after finding the correlation coefficient, we need to test the significance of the coefficient. Now, the data that we used to calculate the correlation coefficient was a sample data. Okay, it was just a sample data taken out of a population data. So now, can we use the sample correlation coefficient to make an inference about the population correlation coefficient? In other words, can we, based on the correlation that we are getting between the two variables, based on the sample data, to say that there is also going to be a correlation between the population data for the two variables? So we'll have to test for the significance of the correlation coefficient. So now, just assuming that we use rho to denote the population correlation coefficient, then we want to test for the significance of this rho. If the rho is equal to 0, then it means that there's no relationship between the population variables. So there will be no correlation at all. But if rho is significantly different from 0, then it means that there's a relationship between the data, even at the population level. Okay, so we have to construct a hypothesis test and test to see whether we can use the sample correlation coefficient to make an inference about the population data. Okay, so let's look at the steps in doing that. We know hypothesis testing, always we have to state the null and the alternative hypothesis. So here the null hypothesis is rho is equal to 0. So if rho is equal to 0, it means that there's no correlation between the variables in the population. And then H1, the alternative is rho is not equal to 0. If it's not equal to 0, then it means there's a correlation between the two variables in the population. Okay, so this is the first step. Because of the equality, we are talking about a two-tailed test. After stating the hypothesis, we choose the test of statistic. Here we use the T stars. Okay, so there's a formula for finding the T statistic. This R is the correlation coefficient. This N is the number of observations. We are using T stars, so we use the student T table. So we want to find T alpha. The T critical is going to be T alpha with degrees of freedom n-2. I hope you remember how to read the T table. So first, use the formula to calculate
Yes,
the T.
sir.
Yeah. Use the T formula, the T statistic formula to calculate the T stars. Then you will need to find the correlation and the T critical from the T table. The T critical from the T table. So after finding it, the decision rule is that I'm sure you know if the thing is two-tailed, we have two rejection regions. Let me do that. If the test is two-tailed, okay, then this side is T alpha on 2, and then the degrees of freedom, the minus T, and then this side will be T alpha on 2, and then the degrees of freedom. This is the acceptance region for the null hypothesis. And then this side and this side are the rejection regions. So one, we will reject the null hypothesis if the T statistic is greater than the positive T critical. Okay. So the value that we reach from the table is we'll have a positive one and then a negative one. If the T statistic is greater than the positive one, we reject HO. Or if the T statistic is less than the negative one, that's the left tail. If it's lower than that, that one we reject the null hypothesis. Okay. So it is supposed to be 2. The decision rules are 2. You know them both, and then depending on the T stars that you have, you can make your decision. So if we reject HO, then we want to say that there is a correlation between the variables in the population. Otherwise, if we fail to reject HO, then it means that there is no correlation between the variables in the population. Okay. So let's look at an example. We are assuming the correlation coefficient is minus 0.871. N is 10. And then we have to use 5% significance level. So how do we test the significance? First, you need to state your hypothesis. So your now rho is equal to 0. The alternative rho is not equal to 0. Tina. Then you have to calculate your test statistic. So T is equal to R square root of n minus 2 over 1 minus R squared. This is R, so just substitute your R. N is 10. So just simplify, and then we are getting minus 5.014. Okay. So the next one is to find the T critical. The degree of freedom here is 10 minus 2. That's going to be 8, right? That's going to be 8. So let's check the table. Oh, I think I even have it. Can you see the screen? Can you see the table?
Yes, please.
Okay. Even the table to you have to be careful which one is given to you. If it's two-tailed, then we are just using the 5%. But then if it's one-tailed, then it's 5% divided by 2. So that would give us 2.5. But this table captures both the two-tailed and then the one-tailed. So if it's two-tailed, 5%. If it's one-tailed, 2.5. So this is a column we are on. Then we just check the degree of freedom. It's 8. So 8 and 5% two-tailed is 2.306. So this is the T critical, but no, it will be positive and minus, okay, positive and negative. So this is what you have. This side will be 2.306. This side will be negative 2.306. But the T statistic was minus 5 point something. So you see that minus 5 is less than minus 2. So what do? We reject the null hypothesis. Since minus 5 is great, it's less than minus 2.5, 0.306, we reject the null hypothesis. So rejecting the null hypothesis means that there is some level of correlation between the variables in the population. Okay, there is correlation between the variables in the population. So please, when you let's go back to the those we were using. I think there was some inconsistency here. After finding a T critical, they compare the T stars to the T critical, and they say we should accept the null hypothesis. No, we don't accept it. Okay, but look at what they stated here. This means that there's enough evidence to suggest that the value of rho is different from 0. Hence, there's a correlation between the two, but you are saying we should accept the null hypothesis. So the decision is wrong. Okay, the decision is wrong. It's supposed to be reject the null hypothesis, which will mean that there's correlation between the two variables. So please, when you are going through it, you have to check it. Okay. All right.